Hello everyone, I am S.L. Sangre working as a lecturer in Kekewak Polytechnic Nasik. We are going to learn basic electronics course. Code for this is 22225. Unit 2 of this course is diode and their application. And CO applicable for this unit 2 is use diodes in different applications. And marks are 18. Let us see what is a diode. Diode is a active component. Diode having two electrodes. That's why it is called as a diode. We have to see three types of a diode here. PN junction diode, Zener diode and LED one by one. First we will see PN junction diode. This is the construction of PN junction diode. PN junction diode is made from P-type semiconductor material and N-type semiconductor material. P-type semiconductor material and N-type semiconductor material both are joined together. Then negative ions from P-type and positive ions from N-type are combined across the junction which form depletion region. Holes are the majority charge carrier in P-type and electrons are the majority charge carrier in N-type. P-type is generally positive terminal and N-type is negative terminal of the diode. So this is the simple construction of PN junction diode. Now let us see the working. For working we should know what is a biasing. So biasing is the process of applying DC voltage source to the diode. There are two types of a biasing, forward bias and reverse bias. Forward bias means N-type semiconductor is connected to negative terminal of the battery and P-type semiconductor is connected to the positive terminal of the battery. In forward biasing, depletion region is narrow and when the at particular applied voltage, this depletion region will disappear and then current will flow through the diode. Red arrow shows the conventional current and black arrow shows electron flow. Both are opposite to each other. Reverse biasing. Reverse biasing means P-type is connected to negative terminal of the battery and N-type is connected to the positive terminal of the battery. In reverse region, depletion region is wider. That means there is a no amount of current is flowing in reverse biasing, but practically small amount of current is flowing and that is due to the minority charge carrier and it is very small. These are the VI characteristics, forward characteristics and reverse characteristics. So related to this VI characteristics, there are some important terms. First one is a knee voltage. Knee voltage means the voltage at which forward current start increasing rapidly. For example, silicon having zero point 0.6 volt and germanium having zero point 0.2 volt. Next term is reverse breakdown voltage. It is the reverse voltage at which breakdown takes place and large current starts flowing through the diode. In this region, generally operation is avoided because diode may be damaged. These are some applications of PN junction diode. It is used as a rectifier, clipper clamper circuit in feedback diodes, AM detections. Now, Zener diode. This is the symbol of Zener diode. This is the anode and this is the cathode. This symbol is same as PN junction diode, only at the cathode terminal Z like structure is made. So this is the small change in PN junction diode symbol and Zener diode symbol. So Zener diode is a special type of a diode which is used to specify applications. Its construction is same as PN junction diode, only doping levels is different. Zener diode is always operated in reverse breakdown region. It is also called as voltage regulator or breakdown diode. The reverse breakdown voltage is adjusted precisely between 3 volt to 200 volt, and it is done at the time of manufacturing. Now, let us see the working. Reverse biasing. As we know, Zener diode always works in the reverse biasing. So, cathode terminal is connected to positive of the battery and anode is terminal connected to the negative of the battery. This is the Zener diode. Initially, in reverse biasing, very small amount of current is flowing through the diode. As there is an increase in input voltage at particular voltage, current suddenly increases. This is the indication of breakdown voltage, where current suddenly increases. Generally, breakdown in Zener before 4 volt is due to Zener effect and after 6 volt due to avalanche effect. And if there is a breakdown between Z 4 volt to 6 volt, so this is due to both the effect, Zener effect and avalanche effect. So here I can say that Zener diode works in breakdown region due to the both effect, Zener effect as well as avalanche effect. So this is the very important VI characteristics, reverse characteristics of the Zener diode. Here is Vz is nothing but a knee point. After this point, the current suddenly increases. That means Zener breakdown occurs. Zener diode as a voltage regulator. This is the application of Zener diode. As we know, Zener diode is used as a voltage regulator. So this is the circuit diagram of Zener diode as a voltage regulator. This is the series resistance or source resistance, I can say. Current flowing this resistance is Is. This is Zener diode. This is load resistance. This is cathode terminal, means negative terminal is connected to positive and anode means positive terminal is connected to negative. That means Zener is connected in reverse bias. And across this load we are getting regulated voltage. So what is unregulated voltage and what is regulated voltage? Unregulated voltage means there is a continuous change in voltage value, and regulated voltage means we are getting constant output voltage. So to work Zener diode as a voltage regulator, we should bias in reverse. As we know, the current electricity formula V is equal to Vi minus Is into Rs. So due to this, as increase in input voltage, current is also increases. And due to this, series resistance voltage drop also increases across Rs. And voltage across load resistance keep constant due to Zener diode. Now, if decrease in input voltage, then current is also decreases, and due to this series resistance voltage drop also decreases across Rs, and voltage across load resistance keep constant due to Zener diode. In this way, every time voltage across load resistance remains constant due to Zener diode. These are some applications of Zener diode. This is the comparison between Zener diode and PN junction diode. This is the symbol of Zener. This is the symbol of PN junction diode. It conducts in both the direction, that means forward as well as reverse. PN junction diode conducts only in one direction, that means forward bias only. Reverse bias breakdown. It has quite sharp reverse breakdown. PN junction diode not has sharp reverse breakdown. Application for Zener diode is common, that is voltage regulation, and in PN diode it is used as a rectification diode. So we will see these two diodes deeply, that is the symbol, its working and biasing. and also we have studied its comparison. So thank you.